everybody. So, we've been working on this new turbine design, as you know, and we started with this, which is an Archimedes spiral. Now, this is a well-known design. You'll find designs like this, and all we really did was add the cone so that we could stick it onto our ray gun Doctor Who style wind turbine generator, because that was pretty much a universal generator. Now, I liked it because I thought it was kind of cool, but that was about it really. It's a known design. Now, if you remember, we're working on this thing, which is our pelton wheel design, and I noticed that when the wind is blowing on that, then that actually will turn really easily in the lightest of winds. So what we needed was some kind of comparison between this and a well-known design. So I've tested this, and it's about what you'd expect for its diameter and its size and the wind speed. It'll produce around about 200 milliwatts in a 3.4 meter wind, and it is 170 across and 200 high. So that's pretty much what you'd expect it to be. The really interesting thing for me is, what will that do? So if we swap that over, so I've taken this off our universal generator and I've put the pelton wheel on, and all the pelton wheel is now, it's got a cone in the centre for exactly the same reasons. The idea is the wind comes in here, it gets spread gently instead of hitting a back wall, and then gets forced through these blades. Once it gets forced through those blades, of course, it will turn it and it will generate. And what's kind of cool about it is it takes very little wind at all, there we go, to get that thing turning. I mean, that's a super gentle breeze. Obviously, the thing we've got to do now is get some test results on that. Maybe get it to do something. So here's our little test setup to get it to do something. I've got an anemometer, so I've measured the wind speed at that point there. There's our fan we're going to turn on. It's about 3 meters per second. And what I've got is an RAC emergency light. It's a little LED flashing light. We used to take 3 batteries, which I've taken out, and I've connected it straight to the generator, and we're going to turn the wind on and we're going to see if we can light that lamp. Now, there are 6 LEDs in there, and LEDs take somewhere between 10 and 30 milliamps, so we should be getting that. Now, out of something like this, what you're expecting is sort of, I don't know, 90 milliwatts or something, because it's like 140 across and 100 deep, so it's not a particularly big and it's not a particularly high wind speed, but we should get something like that out of there, so we should be able to light that LED lamp for emergencies. So let's give that a go. Okay, let's give it a go. Well, at least you can get it to work as an emergency light. That's pretty awesome. It worked so well in the lab, we thought we'd bring it out to real-world conditions and see how it does, and sure enough, it's lighting up. Now, we're doing this in the daytime, but this is where wind beats solar. You get a bit of a wind on a night, then you've got yourself an emergency light. Solar cells are never going to do that. I did like that, and I thought it was pretty cool. It does a pretty reasonable job, but to be honest, I love this thing. For me, I think it looks really cool, and of course we're looking at Darwin wind turbines where we'll have the funnel and we'll be funneling air in there, but that seems quite successful for what it actually is. Now, this is a lump of plastic and the tolerances on this aren't particularly great, but we're still getting a pretty reasonable result, and I think that's awesome all by itself. Anyway, I hope you enjoyed the video. Thank you very much for watching, and please do remember to like and subscribe.